Okay, girls, now silently observe sounds that occur in your room now. Listen keenly, girls, even if everyone is sleeping at home or no one is around you. Try to listen keenly for a period of 2 minutes and try to identify all the sounds that you can hear. Now, tell me what sounds were produced in the room itself. Maybe a clock ticking, if you have a clock in your room, or some electrical or mechanical devices, even everyone is very quiet. And sometimes and nowadays when it's very quiet outside, there's no car moving and nothing, no voice coming from outside at all. Sometimes even you can hear people breathing, people's movement, the way they walk. They're not in the room, but they're walking outside. The tiptoe, the tapping of their feet, everything you can observe. Those sounds you can hear. So here, girls, each of these sound began as vibration at a particular source. There was some source from where the sound began. And these vibrations, they traveled in waves to your ears. Okay, once again, each of these sounds, what I was telling you to listen, it began as a vibration at a particular source. And these vibrations traveled in waves to your ears. Okay. Now, how would you describe the movement of the water wave? Anyone? Again, it was up and down movement. Now here goes. Thinking of a spring toy, the spring toy can help you understand compression waves. This is a different type of wave again, compression wave. The coil in one area become branched up or compressed. It become compressed. See, or it become branched up. That's what they're saying. A line of vertical ellipse. The left side has ellipses that overlap with an arrow pointing to the right, but as ellipses move towards the center, they become side by side. The coil in one area becomes bunched up together and or compressed, or they get together and then they stretch out or separate. And here 2 and 3, these compressions and separations occur along the length of the spring as the waves move away from its starting point. Are musical instruments are the only things that make sound? No. Even when you're striking the head of the nail with the hammer, it causes some vibrations. And many animals make sound by moving a column of air through the throat and mouth. You have heard the cat making different sounds, some of the birds making beautiful sounds, okay? So that is with their throat, and there is some vibration, the voice box is vibrating inside. All sound vibration travel in compression waves. All sound waves, they say, it travels like this in compression waves. Molecules, as a compression wave moves, molecule of air or other matter are pushed together. They get compressed and then they get apart. Then they get compressed. This is how it's going on with the air, in the air. Sound energy moves away from its source as this bunching and spreading of molecule is repeated over and over until it comes to your ears. Now, your ear detects sound waves when the waves make parts of your ear vibrate. Now, when these vibrations enter to my ear, it goes to my middle ear. We have inner and outer and middle. It goes to the middle ear, and there when this vibration strikes, now my middle ear, we have some special organ that starts vibrating, and then your brain interrupts these vibrations as sound. Then my brain comes to know, okay, this was a sound which came through vibrations. It seems like a long story, but which happens in few seconds. Now here, girls, tell how a compression wave and water wave are alike and different. I've discussed this answer before, and I'll be posting this, or I'll be emailing you about this answer. And until then, girls, please take care of yourself. Simple girls here.